All right, today we're diving into what you might call a cosmic beehive. Seriously, it's one of the most exciting places to watch planets grow up, and it's giving us a front row seat to the whole show.
So, how does the solar system actually grow up? I mean, it's a huge question, right? You see, we found plenty of planetary toddlers, still wrapped up in the dusty clouds where they were born. And we know a lot about mature adult systems like our own. But what about the bit in the middle, the awkward teenage years? Finding those has always been the real challenge.
So to figure this out, astronomers needed something kind of like a time machine. And believe it or not, they found one. It's a star cluster, not too far away, that gives us this perfect snapshot of planetary systems right in the middle of that messy, super important phase, their adolescence.
So what makes this place so special? Let's dig into why their Beehive cluster, also known as Praesepe, or M44, is pretty much the perfect cosmic laboratory for this.
Okay, so the real power here, it all comes down to control. Think about it. Studying random stars out there in the galaxy, well, it's like trying to understand how people grow up by just looking at a random crowd of adults. You have no idea how old they are, where they came from, nothing. But a star cluster, that's totally different. It's like studying a family. All the stars are basically siblings, born at the same time from the same stuff. And that shared history, that makes it a perfectly controlled experiment, just hanging out there in space.
Right. And this is what we call an open cluster. It's just a group of stars that were all born together, and they're still kind of loosely hanging out. Because we know their age, how far away they are, and what they're made of, these clusters are just invaluable. They're cosmic laboratories where all the really important variables are already figured out for us. It makes studying their planets so much more meaningful.
Okay, so astronomers have this perfect lab. Now what? Well, they were ready to tackle a really big puzzle, a mystery surrounding one of the weirdest kinds of planets we've ever found, migrating gas giants.
And this takes us back to 2012, when astronomers announced a huge discovery with, I gotta say, a brilliant title. 2 Bs in the Beehive. Get it? Anyway, they had found the very first planets in the entire cluster, and this was just the beginning.
Now, these weren't just any old planets. Nope. They were both massive gas giants, and they were orbiting ridiculously close to their stars. Just look at those orbital periods. We're talking a year that lasts only a couple of Earth days. These are what we call hot Jupiters.
And that right there is a huge puzzle. See, our best theories tell us that giant planets like Jupiter have to form way out in the cold, icy parts of a solar system. So how in the world do they end up getting toasted right next to their star? The best idea we have is something called planetary migration, that they basically spiral inwards over time. But finding them in the Beehive raised an even more specific question. When does all that moving around happen?
And this is where knowing the Beehive's age is an absolute game changer. We know the cluster is about 800 million years old. That gives us a hard deadline.
Finding these hot Jupiters already settled into their new homes, that was the smoking gun. It proved that this massive inward journey has to happen pretty fast, cosmically speaking. It's got to be all done and dusted well within the first 800 million years of a solar system's life.
But the Beehive wasn't finished, not by a long shot. It had another huge surprise for us, one that showed us what a young, multi-planet system really looks like. And spoiler alert, it's messy.
So you remember that star, Pro-211, the one with one of the first hot Jupiters? Well, when astronomers looked closer, they realized that planet wasn't alone. Turns out it was part of the very first multi-planet system ever discovered in an open cluster.
And wow, what a family portrait this is. It's like a tale of 2 completely different siblings. You've got the inner planet B, that's our hot Jupiter, just cruising along in a nice, predictable, almost circular orbit. But then you have planet C. This thing is a monster, almost 8 times the mass of Jupiter, and it's on this wild, super stretched out, eccentric orbit. It just swings way out and then comes screaming back in.
So what could possibly lead to an arrangement like that? Well, this kind of orbital chaos is a huge clue. It points to a really violent past, probably caused by something we call planet-planet scattering. The basic idea is that in a young system, all these giant planets are gravitationally wrestling with each other, and it gets messy. Sometimes they can literally fling each other around, kicking some planets out of the system entirely, and leaving others, like our friend planet C, in these really strange stretched-out orbits.
And the hits just kept on coming. A completely different tool, the amazing Kepler Space Telescope, would soon find even more planets in the Beehive. And these new guys, they were breaking the rules in a completely different way.
So, Kepler, in its second life as the K2 mission, just stared at the Beehive, looking for these teeny tiny regular dips in starlight. This is called the transit method. You know, when a planet passes in front of its star, it blocks a little bit of light. It's like a tiny moth flying in front of a giant searchlight. And if you look at this data here, you can see it. K2 found that telltale dip.
And what it found was a planet we now call K295b. It's about the size of Neptune, which is interesting enough, but for its mass it was weirdly big. Kinda puffy, especially when you compare it to similar planets around much older stars.
And here's the really cool part. K2-95b wasn't some weirdo outlier. It was part of a trend. This chart here shows it really clearly. The planets found in young clusters like the Beehive, the ones in orange and red, are consistently bigger for their mass than their older cousins. It seems like all these planetary teenagers are a bit swollen.
And this is just a beautiful snapshot of a key stage in a planet's life. What we're seeing is that these adolescent planets are still physically changing. They're still puffed up with all that leftover heat from when they formed. We're literally catching them in the act of cooling down and shrinking over hundreds of millions of years to reach their final adult size.
So, since those first few discoveries, the Beehive has really lived up to its name. Follow-up surveys have confirmed that the cluster is absolutely buzzing with planets. We're now at over a dozen confirmed planets, which makes it one of the richest cosmic laboratories we've ever found.
Okay, so let's wrap this all up. What has this busy cosmic Beehive actually taught us? Well, first, that open clusters are basically perfect laboratories for this kind of work. Second, that giant planets that migrate do it fast, in under 800 million years. Third, that young solar systems can be incredibly chaotic places. And finally, that teenage planets are often bigger, still puffed up, and evolving. It's really our best look at how planetary systems get through their adolescence.
The Beehive shows us what that messy middle chapter of a solar system's life is all about. It's helping us piece together the story of how a calm, stable system like our own actually gets to be that way. And it leaves us with a really fascinating question, right? If this is what a planetary system's teenage years look like, what kind of forgotten chaos is buried deep in the past of our very own solar system?